Hello, welcome to Voyage to Space, where we embark on a journey to better understand the cosmos. We explore different topics related to space like dark matter, time dilation, and what space is. Today on a voyage, we'll be interacting with another explorer on a voyage to the cosmos, a female astrophysicist to be precise. As part of the role model series, we'll be learning from experiences of an astrophysicist on a voyage to space. Dr. Anna is currently a professor of physics and astrophysics at MIT. Her research revolves around understanding how galaxies assembled over time and how the Milky Way came about. She uses the largest telescopes in Chile for this work. I'm inspired by her resilience to keep working hard, despite the hardships you faced during the early years of your journey. The fact that you don't confine yourself to the stereotypes that dictate the identity of a scientist motivates me to do the same. Thank you so much for taking out time from your busy schedule for this call. First of all, what was the motivation for you to pursue your career in astrophysics? When did you know for sure that this is what you wanted to do for a living?
Yeah, I get asked that a lot. I'm one of those weird people who have always wanted to be an astronomer ever since I was little. Not everyone around me thought that that was a good idea, but they just let me be. And the funny thing is that it worked out. Um, so I found some good mentors along the way. That's a story on its own. And I studied physics in Germany. I'm from Germany, and I kind of went from there. So it's I think the important thing really is that obviously one needs to be interested in stars or galaxies and the cosmos and the universe to in order to want to be an astronomer. Finding mentorships is very important. I think these days with the internet, there's a lot more stuff and people available. That was certainly different from when I grew up. And knowing what this career looks like. I'm actually working on a book now that details that a little bit more to give young people a better idea. And you've probably seen TV shows about police officers and doctors and lawyers. And so we all think we know what they're doing in their day job. I mean, I'm pretty sure we don't. Reality is probably different, but we all think we know because we've seen it on TV, right? But where is ever a scientist portrayed like that? So most people do not know what a scientist does. And I had the same questions when I was little. I had no idea. And that's where my mentors helped me a lot. And again, I think these days it's much easier with having material on the internet and to learn about this. So it's easier to chart and to answer that question. Is that something that I want to do with my life?
That's great. And who were your female role models growing up? And how do you think their journeys influenced your path to becoming an astronomer?
I really like Marie Curie. Again, I grew up before the internet. There wasn't much access to many people, including role models, and of course Marie Curie is a big one. I was very inspired, and I read some biographies of hers, of how she did all her research work while having children. And I gave some essays about her in school. I had a very good woman chemistry teacher as well. And once in a while I stayed after the class and we chatted a little bit. And she did take a few minutes to chat because she knew I wanted to chat about that. So that was good. She also very much supported me. Yeah, so it wasn't a lot, but she also, the teacher, she also had several children. And so I knew that it can be done. I've seen it. I know it can be done. And so it was never a question of whether I could have children and be a scientist. I have 2 little children now by myself. So it's fun.
That's great. And what was the process behind writing your book, Searching for the Older Stars, which is a science-based book for a general audience? How was that process?
Long. Writing a book takes a lot longer than you think, and then even longer. I had written some articles for the German version of Scientific American, and so this publisher somehow got wind of my name, and they contacted me if I wanted to write a book about stars. They had no idea about anything else, but they figured a book about stars would be cool. And so I wrote them a book about stars.
That's great.
Yeah.
So in high school, you spent a lot of time in the library reading about your interests. So what were your most favorite popular science books?
I don't think I really had much. I was very much into sports, and then there was school, so there wasn't actually all that much time left. So I didn't do a lot of reading, except for some sort of science-oriented astronomy books. I was watching a lot of Star Trek, so maybe that counts. And that I certainly found quite inspiring, traveling around the galaxy. I wanted to do that for some time. Clearly that didn't work out, but that's not my fault. So yeah, it was just mostly kind of documentaries on TV, the few books that I had, Star Trek, and what's up here. I mean, inspiration happens. I mean, it comes from elsewhere, but if it doesn't, it's only little seeds, right? It has to grow in your head. You need to make something of it in your head, and somehow that's I think what happened with me. I just always knew I love stars.
That's great. So how do you think doing an internship while in high school gave you more confidence in pursuing your dream?
Well, simply along the lines of what I already said, it gave me an idea of what this career looks like, right? Because if you're interested in something, you wanna know more about it. But I asked around, in my family and at school, and nobody really knew how. I mean, most people didn't know what a scientist does, but certainly nobody knew what an astronomer does. As for let's say chemistry or biology, there's a lot of lab work, and that you can kind of picture this after you've done some lab work in school. But astronomers don't do lab work. So what are they doing all day long, right? How does this work? Do they use telescope? Do they have to use telescopes? The answer is no, by the way. So it helped me to really understand what are all the pieces, right? And so computer work, I had no idea really. I mean, I guess I could have guessed, but I wasn't really know how this would work. So I learned how to, use a computer, Unix box, programming and data analysis and data collection and thinking about it, and later on then how to get data from telescopes. And maybe you know this from yourself, it's a little bit like cooking. The first time you feel like you're hungry for some dish, but you've never cooked it before, so you go and find a recipe, but it may not be turning out all that well the first time because you're just kind of trialing and you're not sure if you even like the recipe, right? But you want to kind of try because you're hungry, and then it turns out to be quite tasty. And then, next time you're hungry again for this dish, it's that recipe and this is how it's done, right? So okay, this is something delicious that I want to try again. So well, it's a little bit like that for me, right? Once you have an idea of what this looks like, you can make an informed decision. Am I gonna try again, or is this maybe not for me?
Yes. So how did you remain resilient when your request for an internship at the Gauss Observatory while in high school was rejected?
Well, obviously I was crushed. I wanted to do astronomy, and I thought, like, okay, they are astronomers, why are they not supporting me? But they had a different agenda, and that happens, right? And now that I've been a scientist for a while, rejection happens almost every day. Proposals get rejected, things don't work out. That's some form of rejection. But as a scientist, your job is to ask questions, and your job is also to be okay with any and all of the answers. Yes, no, maybe, perhaps, everything in between, right?
Yes.
And it takes a little while to get used to, and maybe we all never get used to rejection because we don't like it. But when, as people say, right, when one door closes, another one opens, and that's exactly what happened in my case. I found something a lot better. But did that feel good at the time? No. I cried when I came home. But it just meant it wasn't the right thing for me, right? And there's the wisdom of hindsight and all, but it really was just not a no. It was just a not now, or maybe not here. So we all have to struggle through it. And again, the food analogy is you go to the shops because you need that secret ingredient for your dish, and they're out. What you're gonna do, right? So either you do it later, not now, or not here. You have to go to a different store and get it, right? So it's part of life.
That's a better outlook than just saying that, yeah, no, not even thinking otherwise.
Yeah.
So, through your networks at Freiburg, you were able to do your PhD in Australia. So, how important do you think networking is, and how do you build strong networks?
It can be very, very important, but you can never predict when. And that's the weird thing about networking. It's kind of like a bank account. You put stuff in, but you don't know when you're going to take stuff out, right? But it's going to be later. It's for later. I'm saving up for later. So it's good to meet people. You and I, we're meeting right now, right? So we're having a good time today talking about science. That's very important. We don't know what's going to come of this later, right? We have no expectations right now, but maybe in 10 years you're going to write me an email and say, like, hey, remember this interview? I'm in Boston right now. Do you want to have coffee? And I'm like, yeah, I remember that. So that's networking, right?
Yes.
And different people, as with everything, again, in life, you'll likely have friends that are really good to talk to. You have friends that are really good to do things with. There are people who can help you with your math problems, and then some people with your art. Not everyone can do it all, and not everyone should do it all. And again, your network should be the same. You should have connections with different people who have different views and different perspectives, and who can help you with different questions. If you ever want to tap into your network, you need to figure out ahead of time which person would be the best for that question, because it's actually not super helpful to kind of ask the wrong person. Not that they're necessarily wrong. Again, a different perspective sometimes is really helpful, but often I find you wanna start with the best match to kind of just lay out the land, and then you get other opinions on top of that, right? You want to first gain confidence and find an ally. Let's say you want to start a new project, right? You first want to find someone who says, that's a great idea. You don't want to talk to the person who's going to say, are you really sure? Right? That person will bring valuable points to the discussion, but maybe the order matters. Yeah.
So, what does a typical day at work look like for you at MIT?
Oh, I'm not sure that I have a typical day. Well, I have typical weeks. So if I teach a class, which is, most semesters, I have to prepare my class beforehand. Depending on the class, that takes, more or less time. And I teach that, and then I usually have meetings with students, with my grad students, sometimes with undergrads, depending on who's in my group. We'll talk about science. Then, of course, there's always something to write: emails, papers, reports, reading other people's papers. So there's writing every day. This is the one big skill that most people don't know is essential for a scientist. If you hate writing, then maybe computer science is better for you. Because as a scientist, you always have to write. I really like writing, so I work on books on top of that, but that's special. But you still need to like writing, otherwise much of your day is not going to be very pleasant. Yeah, I of course, as a faculty member, I have a lot of committees and other administrative jobs, but that has not always been like that. So the more senior you become, the more service work you have to do. As a young scientist, you don't teach usually, and you just do research, data analysis, going to telescopes, talking with a lot of other people, colleagues, collaborators. You do problem solving all day long, and some problems you'll rip your hair out and others get solved quickly. And again, that's also where a network comes in. Let's say you have a computer problem. Sometimes it's really the fastest way not to reinvent the wheel. You will learn if you ask for someone if they have seen the problem before, and they tell you kind of what the answer is or what worked for them. So not all wheels need to be reinvented, although thinking deeply about a problem and how to solve it first before you ask someone else is always helpful, right? Otherwise you be copycat. And it still needs to crank here, but you don't need to spend 2 hours on the internet trying to find the solution when you could ask someone else, right? So there's no winning there, because you need to solve the problem, you need to move on, because you have bigger problems to solve actually than just a computer bug. Yeah, so that's kind of what a daily week, a day or a week looks like, and it's all on the laptop. Many Zoom meetings, all the writing, all the analysis. So it's just a desk. On the outside, it looks like a desk job. Up here, all sorts of things.
That sounds very interesting. So is it true that research and observations can be a lonely job, or do you mainly work with collaborators?
It's not lonely at all. There's hardly anyone in astronomy these days who works alone. I only work with few people. I'm not part of a big team, and that's becoming the exception, actually. There are very many big collaborations, up to hundreds of people, where everyone kind of works in a team. Still, everyone has their sort of own priorities, and they're well distributed so that everyone has their own thing. But yeah, it's very collaborative, and I have an open door policy. So when I'm in, I have my door open, and people can come in, and so they poke their head in, just say hello, ask a question, or want to talk about something. And so that's actually very typical, certainly in Australia, where I did my PhD, and at my place now here at MIT and Harvard as well, that people are very open talking to each other. And again, as I said, it's also necessary. You always learn something new by talking to someone else that may not help you like right in the second, although it also totally can. But the week later, it's like, that person just said that. Now that makes sense. Or, oh, this is helping me here now, right? Yeah. So it's good. Astronomy is a very, very fun, people-oriented field.
That's great.
At least in my experience.
So how do you manage your time as a single mother, a researcher, and a professor?
Well, I wish I had more than 24 hours in a day. um, I have to be very efficient and fast with my work. And fortunately, I have enough experience, let's say, with writing, and I like writing good enough that and again, writing doesn't take me a long time. That's something that certainly um, uh, takes other people a lot longer. So that, this is where I save a lot of time. And you just have to be disciplined. I no longer really work on weekends, but when I'm in the office, I'm like, getting it all done. And sometimes there are some delays, and it's like, okay, look, there's a delay, but you'll have it tomorrow. And, that usually works.
What advice do you have for high school students who are interested in astrophysics? How can I start learning more about it?
Yeah, so again, there's a lot of material online available these days. Twitter is great. Lots of astronomers are on Twitter, and I would say most are quite willing to strike up a conversation if you ask a question there. And of course, we've just all seen the release of the new images from the James Webb Space Telescope, so everyone kind of knows. So there's a lot that's coming down the pipeline that is accessible to everyone. And there's Wikipedia now. There's a lot of good astronomy on Wikipedia. There are free courses available through a variety of programs. Poking around is the way to go.
Yes. And there's so much to learn in science. How do you manage to remain updated with all the new knowledge?
I don't think I always am. I mean, going to conferences is very helpful. But you hear, people talk, and you get to talk to people. People in my group tell me about the latest stuff if they see something interesting. And again, it's about talking to others and hearing what's hot and what's not. Yeah, it's a struggle. But you do the best you can.
Yes. So what are the future plans for you? Are you planning to work on a different research topic?
No, not something completely different, but as with everything, things evolve. And so I do less finding of individual stars, although I still do that here and there. And the questions are sort of have broadened a bit, because there's been a lot more data and different kinds of data available since I started 20 years ago. For example, the Gaia satellite has released all this astrometric data for millions of stars in the galaxy. And so we can look at the motions of stars now, in addition to their chemical abundances. And so that has opened up a new line of study. And many big surveys have provided data, just not very high quality data from where I'm sitting, but good data to explore sort of more broad questions about how did the galaxy evolve, what do the stellar populations look like, what are their individual origins. And so I think it's important to go with the flow, because it is a sign that we have answered some questions, and now there are the next questions, right? So you want to go from one door to the next, and so it just kind of moves along.
That's great. Do you have any advice for high school students who want to start doing research early on? Do you have any tips for them?
Yeah, that's very difficult. In high school, of course, you don't have much background, and it can actually be very time consuming for a teacher to work with a high school student. I think just starting with reading and listening to interviews like this, and finding out what this career really looks like as much as you can is a good start. Because then if you do ask someone, you can you can show that you've already done a little bit of, poking around, and that you have some knowledge about what this entails. I get a lot of requests that I cannot take because, again, I only have 24 hours in a day. But many also show that that people underestimate how much time it takes, and research is not a quick thing. And so the more a person knows and the more preparation they have, the better the case becomes to then do research. So ideally, I think it's really best to do it during undergrad, because then you know a lot more. But to find like-minded people as in high school and mentorships to really learn about what this all really means, and then to get into actual research in college.
Yeah.
I think that is certainly feasible. And I didn't really do research as a high school student. I dabbled because there were some people willing to spend quite a lot of time with me. I was very, very fortunate. And I wasn't really even getting it when I did it, what gift they gave to me, but it has to be clearly said that is very, very special. Now, there are research opportunities for high school students. There are programs, so that's certainly another option to get into, but usually very competitive. But again, I don't think it is truly necessary. What is necessary is finding other people to talk to about, and finding mentors to talk about, and to read and to learn and to follow, astronomy online, so that when the day comes that you can really start a research project, you hit the ground running, and that's going to make your advisor happy, and that's going to make you happy. You see, it's also about preparation.
So finally, what do you think is the best part of being an astrophysicist?
Oh, many things. Well, I really love using telescopes and traveling to the observatories and seeing the stars above me at night. And so traveling in general is exciting. And so there's lots of conferences to go to. But I mean, I can structure my day often how I like it. That doesn't change my responsibilities, or that I want to really finish this paper. But if I feel like I want to work more at night because I'm more awake then, or early in the morning, nobody really cares. So there's a lot of flexibility, and certainly having kids, that's been very important, right? If I need to take them to a doctor's appointment in the afternoon, I can just work 2 hours in the evening to make up for that, right? And so that's not a problem. And so I very much value that flexibility.
Thank you so much.